All right, welcome back. We're going to look further into stretching parabolas of different forms. And so we've been discussing, I guess, our traditional quadratic formula that looks like that. And I guess if we were just to look at this component of being x squared, then we introduced a coefficient of x squared being a, and what it would look like if we increased or decreased that value, or made it positive or negative. Basically, it went up or it went down. It was either skinnier or it was wider. So it affected the dilation of the parabola. And then we introduced the constant, our c value, which is our y-intercept. Okay, so could be our y-intercept as one option, or it is probably better to be known as our vertical translation. So, which direction it goes up or down. Okay, now we're just looking at this form, and y is equal to x minus h all squared. And in one ways, I guess it is a perfect square when you factorize things. Okay, so again, I'm reverting back to the previous chapter of quadratic algebraic expressions or quadratic equations. And if we had something like, let's say, x plus 2 all squared, you should know how to expand that to become x squared plus 4x plus 4. And that's our y equals, that would then kind of bring it back to the traditional trinomial form factor. But if we were to factorize and come back to this, then we are entering into this perfect square formation. Okay. So that's just a brief connection in regards to the previous chapter to this and where x minus h all squared comes from. But all I want to do in this video is to show you, well, what happens when we manipulate the value of h in our equation. Okay, so we'll move on to back to this graph here. All right, so just make sure that everything's all set up properly. Excellent. So what we have here, again, back to the start, we've got y equals x squared. So that's our base parabola, okay, that we're wanting to compare everything to. So now we're, instead of adding a constant or adding a coefficient, all I'm doing is adding a value and adding 2 to x, okay, but within the brackets. And what we'll see is that the translation is not vertical, it doesn't change any dilation, but it translates it horizontally. Okay, so positive 2 is going to shift it 2 units to the left, and then using the same logic, which seems a little bit opposite in this case, and negative 2 will shift the parabola right 2 units. Okay. Will this apply the same thing to negative parabolas? Yep. Okay, so here we have a negative parabola. It's inverted, but then it's shifted left to 3 units with a positive 3. And then if we had a negative 3, it's going to shift the parabola right 2 units. Okay, so there's that aspect that I want you to be familiar with when manipulating with certain values, in this case, the variable h. So I've got a few examples here where we're going to match the equation to the graph and just using our current knowledge of what that value h does. Okay, so here we have a. We know that it is inverted, which means that it can only be either number 4 or number 6, okay? Because they're the only two equations that are negative, okay? So that's the first thing. If you're able to identify this, then you can use the process of deduction and eliminate options that just don't make sense. we can see that from the origin that it has moved towards the right 2 units. Okay, so if it's moved right 2 units, we need a negative h. So negative h moves to the right, a positive h moves to the left. Okay, so we want h to be negative 2. In this case, it's going to be that one. Okay, so I'm going to write down here y is equal to minus x minus 2 all squared. Okay, let's look at question number 2, or B. In this case, it is upright. So we can eliminate 4, we can eliminate 6, obviously, because this is an upright parabola. And has it moved right or left? It's still at the origin here, so that means no movement or no translation going across. And it also hasn't gone up or down either, so neither of those options work. So that means it has to be 2. So this is y is equal to x squared. And the third one, we can see that it has moved to the left 3 units. It is also upright. We can say that we've cancelled that middle option. If it's moved 3 units to the left, therefore h must be a positive 3. Okay, so we can see that 5 is out because it's a negative 3. We don't want that. We also can see that 1 is out because it's a negative 2. It's not even a 3. So we can cancel that out, which leaves us with 3. So y is equal to x plus 3 all squared is the equation for that graph. Something else that I want to highlight are both, I guess, the turning point as well as the axis of symmetry. Okay, so what we can see when we shift things either left or right, again, positive h moves it to the left and a negative h moves it to the right. We can see that we have the axis of symmetry as 2. So axis of symmetry is x equals 2. In this case here, we have axis of symmetry where x is equal to minus 2. And in this case with the last one, we have an axis of symmetry where x is equal to 3. The turning point is the same. So let's say the x coordinate of the turning point is 2. It is negative 2, and it is positive 3. So just by looking at the graph here, or the equation here, we can establish that this value here, negative h, is going to be the same value for axis of symmetry and the x coordinate for our turning point. Here we have turning point being 2 and 0. Here we have our turning point as negative 2 and 0. And here we have our turning point being 3 and 0. So whenever, obviously we haven't done any vertical translation, but purely based on just this model here that we have right now, these are the two things that I want you to take away from the turning point as well as the axis of symmetry that they have in common. The last element that I would like to explain is how to get the y-intercept from this equation. And what I'll do is I'll focus on the first two questions of D and E. So I might just erase all of this to give some space. And the y-intercept is found when x is made 0. It's the same rule with linear equations, straight line graphs. Doesn't change, or it's no different to quadratic expressions. Obviously, when you look at a Cartesian plane, anywhere along the y-axis, x is always going to be 0 in that value. So that's why you substitute x for 0 to work out what our y-intercept is. Okay, so that's the first rule of thumb. Just recap into linear equations or linear graphs, and we're going to apply that into the same thing here. So, for example, with this equation here, or this graph, we can see that we have a y-intercept of 4. Okay, and so if we have the equation of y is equal to x minus h all squared, we can see that it's moved 2 units to the right. So we'll have y is equal to x minus 2 all squared. Now, because at this stage we haven't done anything else to the graph, I'd like to prove to you and show you how the y-intercept is 4 with this particular equation. Okay, so again, we're going to make x equals 0. So that means we have y is equal to 0 minus 2 all squared. Y is then minus 2 all squared, and our y-intercept is equal to 4. So minus 2 all squared is 4. Therefore, our y-intercept is 4 when x is equals 0. Okay, so just a few things there. Please do not confuse, I guess, the constant, because that is in a different form factor of our quadratic function. You don't need to worry about that right now. All I want you to understand is that the h value is going to shift it left or right, and it also corresponds with our turning point value, our axis of symmetry, and just to identify how you get your y-intercept in this formation. Okay, I'd like to finish off with a problem-solving question or two. We'll start off with question 11, and it does require a little bit of time, a little bit of problem solving, I guess troubleshooting in terms of your thoughts and just how you piece all the puzzles together. So here we have a rule from the graph. Again, y is equal to a outside of x minus h all squared, where the y-intercept is minus 12. So that means, just as a note, when x equals 0, y is equal to minus 12. Okay, and the other part that we also know is that the x-intercept is at x equals 2. So that is when y is equal to 0. Okay, so piecing and connecting things that has been taught in the past to this context, and hopefully you can make those connections from prior learning. So this first step here is when y equals 0, okay, we want x equaling 2. So we have an x, I'm going to make it minus 2. So this, I want you to connect to the null factor law and how you would actually put this together to get that. So remember, x minus 2 all squared, that's basically a perfect square, x minus 2, x minus 2. Null factor law will basically say x minus 2 equals 0 and x is equal to 2, because you move this across to the right hand side by adding, and you get x equals 2, which fits this description as the x-intercept. Okay, so we can probably start off with saying that the equation looks like this. Okay, but the problem here is we want a y-intercept of minus 12. So how do we get to here when we substitute x for 0 to get minus 12 on the side? Okay, so just a thought there, and this is why they've suggested this letter A or this other pronumeral at the front. And so this is where, I guess, again, it comes down to trial. It could be trial and error, but I want you to kind of figure it out through some logistical approaches here. So minus 12 is equal to something that we don't know. 0 minus 2 all squared as our base structure right now. Okay, so we know that minus 2 all squared is 4. And 4 times a is equal to minus 12, which is just 4a. And we can say that a is equal to minus 3 just through basic linear equation solving. So now what we have in the end, our equation for question 11 is going to be y is equal to negative 3 outside of x minus 2 all squared. It has the x-intercept of 2 because it's moved to the right 2 units. And then when you substitute x for 0 to work out the y-intercept, we end up getting negative 12. So we've met both descriptions. Okay, so just to finish off with question 12, we've got a bridge and there's a set of axes being superimposed, a lot of words here, but we've got two sets of coordinates to show that the possible equation is this written here. Okay, so with our first coordinates, we have x and we have y. Again, we have x and we have y. Now, the easiest part from here to look at is we already know it doesn't really matter because we've got a negative value and it's a whole string of really weird decimals. Don't want that to throw you off, but we have a minus 200. And so what I want you to understand here, y is equal, with the first set of coordinates, y is equal to 0. Therefore, the 200 is the x-intercept. Okay, and then with the second set of coordinates, x is made 0, which is stating then the y-intercept is negative 75. And all we need to do is just prove that to be the case when we substitute those values across. Okay, so let's start with say y equals 0. Okay, so when y equals 0, so we've got minus 0.001875, then x minus 200 all squared. We're going to solve for x. Okay, we can basically divide both sides by that number and it's going to cancel out. Null factor law, x minus 200 is equal to 0, x is equal to 200. Okay, so that's our first value for the first set of coordinates. Then when we look at the second set of coordinates, we're going to, instead of make y equals 0, we're going to make x equals 0. So we'll have y is equal to negative 0.001875, and then in brackets minus 200 all squared. Now 200 all squared, let's get the calculator, is going to give you your value of 40,000. Now that sounds pretty big, and it is. And in this case here, all you want to do is put that into your calculator. So 40,000 times negative 0.001875. And when you're using calculator, please make sure that you are ensuring that you've typed in the correct value. You don't want to leave out a digit or press the wrong number, and you'll end up getting y is equal to negative 75. And that fits with that set of coordinates. hopefully that helps you guys. If you got any questions, let me know. We're going to build again through this form factor in the next video. All right, see you next time.